Hi guys, welcome back to another video. Today we're going to be looking at the following math counts problem that looks at some basic principles of counting. And so let's start with a quick read. How many ways are there to color the 4x4 grid shown below so that each unit square is red, blue, green, or yellow, and so that each unit square is the same color as exactly two of the unit squares that share a side with it? Okay, so for a question like this, I like to start by just experimenting a little, right? So we have these four different colors, right? And just to be generic, let's just say the four colors are, let's change this. Let's just say that our four colors are A, B, C, and D, right? A, B, C, and D. So let's start here. If this is A, it says that each unit square has to touch exactly two other squares with the same color. So a corner piece like this cell number 1, if for this to be the same as two other squares that are adjacent to it, that must be these two squares, right? Because these are the only two other unit squares that share a side. Okay, so now let's look at cell 2, for example, right? It's already sharing this side right here with an A. So what's the other possible side it could share? It could either share this side here, so we call this A, or it could share this side here and call this A. Right? So we have these two options. If we start with this, right, we have A. Notice that all four of these cells satisfy the conditions, right? Whatever A I pick here, it's touching two other cells, right? Like cell 6 is touching 5 and 2. Cell 5 is touching 1 and 6. So this works. And this kind of tells us that any 2 by 2 would give us, would basically satisfy the conditions. And then we also know that if we look at cell 10, for example, this cannot be A. This has to be some color B, because cell 6 already touches 2 and 5. So it cannot also touch cell 10 with the same color. And so now if cell 10 is B, we have to think about two of the other cells. What other cells could be B? Now, obviously cell 6 is already taken, so we're left with either 9, 14, and 11. And of these, we have to pick 2, right? And you'll see that, for example, if I put a B here, right, that restricts my option for these lower cells, right? Because what happens is if I do 10, 11, 14, and 15, these four, if I call these B's, then that works, right? There's nothing wrong with this. But 9 and 13, there's no color I could put for 9 and 13 that satisfy the conditions. And similarly, I can't go, if I put B for 10 and 11, then my other option is to put a B. Instead of putting it at the 15, I could put like a cross, right? This is another option. But this doesn't work because if you think about it now, our 13 would have to be a B for the 9 to satisfy the conditions of this and this, which means 14 would also have to be a B. But at this point, cell 10 is touching 3 B's. So this doesn't work. So kind of experimenting like this, that tells us that I could do 2 by 2s. So I could do something like this, right? I could just break this up into 2 by 2s, right? Something like C, 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 and then D, 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 right? So this works. So let's just keep track of this. Let's say we have, instead of 4 by 4, you're seeing these as 2 by 2s, and this will all be A, these will all be B's, C's, and D's, right? So call this, if we do this in red, like this whole thing is A, this whole thing is C, this is B, and this is D, right? So that's one option. Now what I could also do, however, I could make this an A as well. And notice this works, right? Because this cell 11 only touches 15 and 12. It doesn't touch any of these cells in here, right? So none of these cells are touched. So I could at the same time have something like A, if I call this B, C, and call this A again. Or I could flip-flop, and I could say, if we move this over, I could also say I have something like, so I could have these two be the same colors and call this B and D, right? So something like that. And then lastly, for these 2 by 2 patterns, I could have just A, B, B, A. So this is all we could do for just a normal filling up the square with 2x2s, right? Like that basically ends that part of it. You might say like, okay, now we just calculate this because we're pretty much done. But there is one other solution that's kind of easy to miss, but it is nonetheless a solution. Again, these have to be A's. We know this, right? Now, if you remember, we put A in cell 6 last time. It started working. Now, the other option was putting it here. Now, if we put in 3, then it has to go in 4, and it has to go in 8. And then similarly, you can kind of just work your way all the way around, and you get something that looks like this. So along the border, I use one color, right? And that all works because any cell I take is touching 2 cells of the same color. And then my middle square, my middle 2x2 is a different color. We call that B, say. So these are all going to be B. So this is basically all of our possible options, right? I have the 4 kind of 2x2 cases, and then I have this kind of extra case. And so now our problem is, how can we solve this, right? So let's zoom out and let's start working on this now. So remember, A, B, C, and D just represented any random colors. So if we start with our first option, which was A, B, C, D, all quadrants are different colors. So how do we do this? This is just, we have 4 ways to figure out which color is going to be A, 3 ways to determine B, 2 ways to determine C, and then 1 way for D, but we don't really need to include that. So that's 24 ways to put my colors in the ABCD grid. Okay, so we could write that down, 24, right there. Now next we had, if we look at the next case, it'd be something like this. So it'd be like A, B, B, C, right? Something like that, where basically one pair of corners are the same. So here I have 4 ways to pick which color is the same, right? So 4 ways to figure out which colors are B, right? Which color is used twice. Then I have 3 ways to figure out A, 2 ways to figure out C, right? So that's another 24. And then at the same time, I have something that looks like this, where instead of the bottom left and the top right, it's the top left and the bottom right that are the same. So something like that. And this is just symmetric. These two are the same. So this would also be 24. So let's just circle the total cases so far so we don't miss them. Right. And now our last one that we have to consider is the AABB. So there's 4 ways to figure out color A, 3 ways to figure out color B. So that's just 12. Okay, so that's all of our 2x2 cases. And now we just need to figure this last part out, right? This case where I put one color along all the borders and I have a color in the middle. So for the color along the borders, there's 4 ways to figure out which color, right? Red, blue, green, or yellow. And then I have 3 remaining colors to pick from for my middle block of 2x2. So it's another 12. So now in total, if we kind of zoom out and look at all of our values, we ended up with 24. So how many 24s do we have? Let's just mark this. We had 1, 2, 3. So 24 times 3. And then we had 12. And how many 12s do we have? We had 1, 2 12s. 24 times 3 plus 12 times 2. And this is just 48, 72 plus 24, right? Because we want to add these two together. So we get our final answer of 96. And thus, the answer to this question is 96, right? And just to make sure, the question is asking for how many ways are there to color the grid, which we found to be 96. And that should conclude this question. So if you have any questions on how we got to 96, please be sure to leave a comment. And if you enjoyed the video, like and subscribe really helps us out. And that should be all for today. So make sure you join back again tomorrow for another problem. Thanks to everyone for joining, and I'll see you again in the next